This is a version recorded at home of a presentation that I gave at the University of Milano Bicocca, an invitation by Professor Emilio Padoa Schioppa. So, what was I speaking about? I was speaking to students, high school students, so the presentation is not very complex. It's at a level that I hope students could understand, but I still try to give them an image and vision of what is the attitude of human beings, of us, toward the future, because for us it is rather normal that we are interested in the future, especially if you are a student, a high school student. You have a lot of future, at least you hope, and you would like to know something about your future. But how do you do that? And there is a whole story, a whole development, a whole evolution of the future. And I started by showing to the students this book, The Limits to Growth, or this is the Italian version, but it's okay for you. You know what I'm discussing about, The Limits to Growth, Limiti dello Sviluppo, which was published in 1972, and it was really a milestone in the way we have to understand and within some limits predict the future. It was, however, badly misunderstood by people who didn't really know what to do with the study, which was different from everything done before, because in our modern time we tend to think of the future in a linear manner. Things move at the same speed, go on, move on, and our time is linear, yes, even though our watches are round, they still move linearly around the dial. They move at the same speed. Long ago, it was not like that. It was different. Watches, there didn't exist watches, but for instance, the time, the hours of the day changed in duration during the day. Some hours were longer than other hours, which is sometimes you have this impression even today, but we should not say that. So, what is the point? How do you place yourself with respect to the future? And you have to think about that, because our ancestors long ago started thinking about that and maybe writing about that. The first writings we have about from the Sumerians 3,000-4,000 years ago, even more, they started talking about in terms of omens. Omen, it's something you see something and that omen tells you something about the future, which is logic. It's a way they had to try to understand the future. See a dark cloud in the sky, well, it will rain. It's an omen. They didn't know really what cloud was made of. But they could understand this. That method was very empirical. You could say, I saw a black cat crossing the street, then I will have, I break a leg or something like that. And that was not so good as an omen, but we still have it. So maybe there is something right in this idea. Probably not, I'd say. And the ancient had a structured approach to the future. They searched for a logic. They believed, not without logic, that the universe had some laws, some inner logic, ways to function. And the way to predict the future was to try to understand this inner logic, and if the gods were managing the universe, then it has a certain logic to ask the gods in some way. Okay, let me show you the image I started with, which is the Pythia, or the prophetess of Delphi, the oracle of Delphi. She was a young lady who was forced, or maybe she liked that, to sit on a sort of high chair on top of this pit that you see below here, which was said to be the place where an ancient deity in the form of a reptile reptile people, or reptile beings, reptilians, they're fashionable still today, died, and slowly decomposing, it was breathing out this smoke, which you see here, and the pythoness or the Pythia or the prophetess would inhale this smoke. It must be very bad, I suppose. She would start prophesying, telling things, which was, I'm sure, was spectacular, but there was a logic in the whole story. It was not just a young lady doing that. It was because you had a whole priesthood around the oracle, and they were analyzing the data they received from the people asking questions. When you ask a question, you reveal something about yourself, and these are data that you can process. That's what you do with modern artificial intelligence systems. You ask questions, and in asking questions, you give data to the system. The system will then process the data and give you an answer. They were doing the same. Imagine that a king would go to the oracle, and they did. I say, hey, what will happen if I attack my neighbor? But they will tell you something a little not so clear, but it's an old story, probably the story of Croesus the king. And he was told a mysterious oracle that he understood as he would have won, then he lost. But then it meant it's not that the oracle was wrong. He hadn't interpreted it the right way. But the fact that Croesus went there to ask what would happen in case he was to attack another country, another region, and there was an information that the oracle could provide to others. And so there was a perfect logic here. You had a information processing center, and it was very popular in ancient times because it worked essentially. The ancients were not stupid, and they used what they had, and they used it reasonably well. Then, of course, things changed, and we moved to a more linear vision of the universe. And let me show you another slide, this one, another image. Things are changing. We're changing. We're moving to modern times. We are around 350 of our era, and this late Roman times, late Roman Empire. And I asked to the students, can you find here something very special which tells you something about the universe, how the universe evolves, and which was never shown before in any ancient image we know of? Now you're listening to this presentation, maybe you can try yourself to take a look and see if you can see this curious object, which is an object already. I told you that it is an object. You have a clue, but the students couldn't make it. Maybe you can, but I made a little scene here to show you this box. That is the secret of the universe, and you do this to attract the attention of the audience. Of course, little tricks you play. So I had this is a mysterious box. What is inside here? And then I showed it to them, all wrapped in paper, but doesn't matter. And here you go. Stained glass or hourglass, you know what it is, and you can find it in this image. You see this here, but the scene here behind the glass. This is the first image of a stained glass in history. It means that it already existed in late Roman times, which was a big advantage. And it was a sort of linearization of time, because before the stained glass, which is a reasonably linear object, before there was the water glass, the clepsydra, which probably this strange object, this strange tube is a water glass, but I'm not sure about that. But it was not linear. It changed the speed as a function of time. This was a very interesting object, a system which went down constantly with time. The properties of this arrangement of objects, it's a whole physics of hourglasses. People publish papers on this. And in reality, the stained glass is a more complex object than what it seems to be. Because, you see, below this there is a mound, there is a sand pile which forms at the bottom. And this sand pile had not been understood or observed before, maybe it was, but only recently we started having the mathematical tools that would be needed. Let me show you how it works. It is this sand glass little film, little clip that I made. You notice how the pile goes down in avalanches or landslides, or you want to call it. And these landslides are not of the same size, and they do not occur in constant intervals. It goes up and down and up and down, and that's something that one scientist named Pierre Bach was working at the Brookhaven laboratory near New York. He observed in the 1980s. He said, "Well, this is strange. How could I analyze it?" And then I will show you how it can work. And that it was the first development of a completely new field of science, which is called self-organized criticality. Well, nice name, but it's a very simple thing. You see, good physics very often is done starting with the observation of simple things, which are simple phenomena, but which have a deep meaning inside. So what can you do? This is the future in a certain sense, because to show you that the future is not linear, you cannot predict when an avalanche will take place. Not exactly. You can say something statistically about how large these lights are, but one of the results of this new science, science of organized complexity, critical, self-organized criticality, was that these avalanches are unpredictable. Yet you can say something about that, and you should know that you can be prepared about avalanches, because the world is made in this way. It is never linear. It is a series of waves, of one kind of another, water waves, sand waves, and what you see here, this image, is from the cover of the book that Pierre Bach published in 1980s, and you see he emphasizes waves. These are sand waves, not in a sand glass in the desert, but this phenomenon is very similar. The world moves by dissipating energy, by using these waves to carry energy from one place to another, and sand glass is dissipating gravitational energy. You have to give energy to it in order to make it start dissipating. And there are dissipations which are much more spectacular than this. For instance, we can spend a few minutes looking at this clip. And make some catastrophic movie and show this to students. So I think they liked it. I hope. You see, I don't want to make it a catastrophic movie, but just to show you how an intuition that the Roman philosopher Lucius Seneca had during the first century of our era, said he noted this the way the universe works. And it was a good intuition because he didn't have mathematical instruments to describe a wave, to describe this phenomena. But he said in a letter to a friend, say, you know, Lucilius, would be nicer if the world were different, but as things stand, increases are sluggish growth. And the way to ruin is rapid. It is what I call the Seneca effect, and it's sort of popular. You can find it on the web, the Seneca effect, and you see these curves of the limits to growth studies are like this. They grow slowly and then they fall rapidly. And generally speaking, these curves have this shape, which sometimes you call it the bell-shaped curve, or sometimes the Hubbard curve, because Hubbard was the person who proposed this curve for some phenomena that occurred in the extraction of oil. But really these things are known much before Hubbard. They were found, observed, and reported for epidemics. What you see here are these bell-shaped curves. On top left, you see the very first bell-shaped curve for an epidemic shown to the public on in this case, on a newspaper, the New York Post, on 1849. And they are for the number of infected and the number of deaths for a cholera epidemic. Note how how big is the text for this image, because the editors said they understood that the public was not used to this kind of thing. They had to explain what happens. Just to read this graph was not easy for people unprepared to be able to reading Cartesian graphs. Not easy still today. So they explained it in detail. But you see, when we arrived to the COVID pandemic of 2020, you had the same curves. This is the curve for infections for Italy in 2020. The shape is the same, but even in that case, people had serious difficulties in understanding how it works and why it works. We heard the strangest things said about this curve. Some people say, oh, it's growing exponentially. We are going to die. All of us are going to die. No, we are not, but it was difficult to explain. People look, the initial part looks exponential, but doesn't keep growing exponentially. It will abate by itself eventually. But there's some people understood it in some ways or another ways, like you remember the story of flattening the curve, which never worked, could not have worked, and it would never, was essentially a fad. But it showed at least how people can misunderstand this kind of things, because there is a theory, there is a logic. Seneca could not work with these symbols. He didn't have these tools. But the study of this curve, this initial exponentially bell-shaped curves, starts in the 1920s, when some people developed a model which is called SIR, susceptible infectious recovered. And I'm not showing you the details of these curves, but just to tell you that there is a certain logic which can be put in a mathematical forms. It tells you only that, yeah, if you are a virus, you are dissipating energy, you grow on eating cells or predating cells, you dissipate the energy inside your target, your victim, and then you reproduce and you keep growing and doing it more. And then as you keep growing in numbers as a virus, then eventually you run out of targets because people become immune or die eventually. And so eventually you have no food, and then your number should go down, and then eventually the epidemic disappears. About the same time as it was developed, this theory in epidemiology, as other people, Alfred Locke and Vito Volterra, two mathematician and a physical chemist, they developed the same theory, essentially. It will be more complex, but essentially the same for biology, which you're a predator and prey. Sometimes it's called the foxes and rabbits theory. You have a predator, the foxes, which feed on the rabbits, so they kill so many rabbits that they die of starvation, and that the same fate as viruses. So there is a logic, but it is not so easy to explain it to people, and this is the reason why the limits to growth was so misunderstood, because essentially it used the same mathematics which describes viruses or hypothetical foxes in an island, but a little more complex. But in that case, the predator is us humans, the human economic system, and the results are produces curves which are similar to those of epidemiology or biology or oil extraction, which is a fraction of the human economy, because the economy grows on exploiting a resource, which is here is shown in shown in red, and as you gradually run out of the resource, you never really run out of the resource. Look this, even when at the end of the cycle there is still resources available, but you grow, the system grows, industrial production is brown, agricultural production is this blue or light green curve, and as you gradually have less resource, it becomes more expensive to exploit it, and so eventually you cannot grow anymore. You start going down, just like in an epidemics. And there is another parameter here, which is the pollution, which didn't exist. It was not considered at the time of the epidemiology or biology, but it exists in our system. It was very important. 1972, they still didn't have it clear what was global warming, how important it was. But this curve, this dark green curve, represents the growth of something, a kind of pollution, any kind of pollution which weighs down the economic system and causes, in part, is one of the factors which cause the decline in production, ruin of the system, which the system, as you see, as Seneca said, the system slowly grows and then it goes in ruin. And the population, the human population, also eventually will have to stop growing, because the growth of the human population depends on the availability of resources, or processed resources, by the agricultural and industrial system. In this case, we have a gap of about 50 years between the collapse of the industrial system and the collapse of population. In reality, this depends very much on assumptions. More recent models show that the thing happens together. The population starts declining shortly after the decline of the agricultural production, as you would expect it to happen. And this is a very fundamental point. You see, this study here, it's in line with what we know about how the future works. And also in line with the way our ancestors, let me repeat, they were not stupid. They understood the future to grow, to go in these cycles. And what the people who prepared this study did, was to put this concept, which was typical of the Stoic philosophy at the time of Seneca, they put it in a mathematical form, which was not possible at the time. Now it is possible, but attention, the future is never fixed. This is not a prediction. It is a possibility. It is a scenario. It is a projection. So, well, if you keep doing the same things over and over, and the parameters remain the same, then you probably have something like that. But in future, just like the Delphic oracle, you would not have clear-cut and fixed prediction. You, Mr. Croesus, you go to war with the Persians and you lose. No, it depends. Indeed, if you when people start a war, both sides must think that they can win it. Evidently, one of them is wrong. So there are a lot of predictions, or possible scenarios, or ideas about what could happen in this study, depending on the assumptions. The future is flexible; it changes. You can stabilize it. You can grow faster and then collapse more rapidly. It happens. It happens. It could happen, and so as always, the future is in our hands. We work on it. As we work on it, it changes. These models help us understand what we can do and also what we cannot do. So we have to keep it in account, but it's not a fixed future. It is an oracle compatible with the oracles. Always tell you, well, yes, maybe this. Be careful, and the future is very dangerous, as you probably can understand. So you have to be very careful with it. But if you can stabilize the future. A lot of calculations in this study were about how to obtain a future which is not like a tsunami waves that sweeps you away. A nice future, which is like waterfall, like the sand when it goes down in a hourglass. And it is possible if we are careful, if we reduce a little bit the speed of consumption, also a lot reduce, if we develop technologies which allow us to do things causing less pollution and not requiring so much raw materials, if we are wise enough to avoid spending our time fighting each other, then we can arrive to stabilizing the energy consumption, the production of society and population too, sort of like feng shui that you can see here, that is relaxing, probably what we want. We don't want to go up and down, we want to go smoothly, and we will see if you, young students, will be able to manage the world in such a way to attain and maintain this condition. Thank you very much for your attention, and I close here, and thank you again.